Now this leads us into the interesting topic of horizontal asymptotes. And you can determine whether or not a function has a horizontal asymptote by examining the limit of that function as x approaches infinity. And the idea is that if that limit equals a number that's not infinity, then there's a horizontal asymptote at that number. Let me show you the graph to show you what I mean. Here's some function here. And what I'm doing is I'm examining this function as we go towards infinity. Now, of course, infinity is this direction, right? So I'm going towards infinity. What's happening is it's getting close to a number. And the number it's getting close to is this one right here. We could say that it's, let's say it's the number c. Let's use a real number. Let's say it's the number 3. Okay. So if I evaluate this function, f of x, as x approaches infinity of this function, and when I plug in infinity, I actually get 3, then I can say, hey, there's a horizontal asymptote at 3, because as I go over to the right really far, it gets closer and closer to 3. That's pretty cool. Furthermore, I can do the same thing for negative infinity. Same function, but different function, same process. I'm examining what happens as I go towards negative infinity. And in this case, it's approaching a number. Let's say the number's still like 3 or something like that. Let's use 4. Spread our number wealth around. So as I'm going to the left, really far, this function gets closer and closer to this asymptote. So I could say that the limit as x approaches negative infinity, or as I go to the left, or really far away, of some function f of x, that equals 4. And so I can say that, hey, there's an asymptote there because this function is getting really close to 4 as I go over to the left towards infinity. That's pretty cool.